Welcome to the Stray Pointers podcast, where seemingly ordinary people join us for extraordinary discussions. You're watching Season 2, Episode 20 of the Stray Pointers podcast. This episode was recorded on December 27th, 2024. I'm your host, Jim Lawless. For more information about the show, including the show notes for this episode, please visit straypointers.com. Rejoining the show this morning are software engineers Juan Vazquez and Cameron Cunning. Guys, welcome back to the show.
Hey, thanks, Jim, for having us back.
Yep.
So we talked about getting this episode out after the first week, and it just didn't happen. That's probably better because we got to see some of the other problems, and some other things happened with the competition. Do we want to start with just talking about some of the challenges and some early memorable ones?
Yeah, that sounds good.
So Cameron and I off camera here, off recording, we're talking about problem 4, Juan, which was the one where you had to find Xmas and then the X-shaped in text. It was called the series search, CERES. And let me share my screen here, and we can see the actual instructions from the page. And what the gist of the challenge was is you were supposed to look for the letters XMAS in any direction, diagonally, up or down, left or right. And then there was, you had to sum them up for the first part of the challenge. So we had a fair bit of discussion about this in IM. Do you guys want to talk about how you tackled it? And then I'll show you what I did.
Well, so I'm still working on this one, and I'm still on part one, and part two sounds terrible. Sounds like you need to find them in the shape of an X. Is that right?
Yes. Mm-hmm.
Okay. Well, I've been struggling with getting all of my types to line up. So I'm doing this in Prolog, and my my strategy was, okay, I'm going to get all of the horizontal rows, all of the all of the vertical columns, and then get all the diagonals, and then put them all into one giant string, and then go through and recursively look for Xmas or SFX. Um, just because, there's no real good regex in Prolog. So, and I think I'm pretty close to getting that solution working, but part two sounds like it would be an absolute nightmare in Prolog. I'm not sure how I would do that.
Okay. Juan?
Yeah, I thought of it as a grid, and then I carved it up by length of the word Xmas. So is that four going across, four going down. So I made my own little squares and iterated through the puzzle that way. That was generally the approach I took. It's funny that you picked this one because this was certainly memorable from my code looking like a hot mess when I was doing it. And what's funny was by the time part 2 came around, I was like, I normally go back and refactor the answer into part 1. This one, I just completed a whole new file, copied part 1, and then changed a few things on part 2 because it was gonna mess with part. It was gonna require a lot more thought to refactor the way I did it than to just put a whole new solution for part 2.
Okay. Well, I'll tell you guys the approach I took. I loaded, I was using Go for the whole competition. I loaded the entire array into memory. And what I would do is iterate through each line looking for the letter X. Then what I would do is look at all 8 positions around X, uh, left, up, upright, right, lower, and lower left. And if I happened upon the next letter, such as XM, then I would recursively move that same direction looking for the rest of the string. So on that particular one, I didn't change my approach. I had kind of a brute force approach on doing I passed in some directions to a recursive function as far as the directions you should change on each axis. And I shortened that a bit by using an array in a follow-up example, but then I just recursively looked for those. So that didn't really take too long to to get to work. So part two was where they clarified that they had misunderstood the assignment, and what we actually had to do was look for the letters MAS instead of XMAS in the shape of an X, where you had 3 diagonally one direction and 3 diagonally the other. And the way that I did this was I eliminated. So in this particular one, I have all 8 of these directions. In this particular one, I eliminated everything except for the diagonal directions. So I'm only looking at 4 spaces, up and to the left, up and to the right, down and to the right, down and to the left. And I'm recursively looking for the name MAS. And I made a map of integers keyed by integers. And when I was finding these letters XMAS, I noted the position of the letter A because and I incremented it because if you have an X, that's referenced twice. So if I happen to find MAS this direction, I would in the map for that coordinate, I would increment it to 1. When I found it then again in this direction, this would get incremented to a 2. Then I went through the map and every place there was an A that had a 2 count, that was the shape of an X.
Very cool. Yeah, as I said, I used a kind of a grid thought process, and so I had the grid hard coded within my to check basically check. I would think like a stamp. Check the
Mhm.
stamp. Is it there? Is it there? Is it there? And that's how I approached it.
Any other examples you want to talk about? Should we talk about number 11, Juan?
Yeah, let's take a
You want,
look here.
you want to do any before that?
11. Let's see which one was 11.
11 was the one that got the most hits on my GitHub page as far as people looking at the source. This is the
Oh,
one that went from 25 to 75 depths from part 1 to part 2.
yeah. Just give me a moment. I got to find how I solve that. With many of these, you spend a lot of time on them, and then you go to the next one, and you kind of forgot how you solved it. And I
Yep.
don't have my code right here in front of me. Let me grab that one.
Let me see here. Sorry, I've got Zoom's toolbar kind of in my way. Yeah, this one was bridge repair. Historians take you to a familiar rope bridge over a river in the middle of a jungle. The chief isn't on his side of the bridge, or this side of the bridge, though. Maybe he's on the other side. Blah, blah, blah. This is the one with some operators. Each line represents a single equation, and what you had to do was apply addition and multiplication between each of these to see which combinations of multiplication and addition yielded this total. That's the very first element.
Yeah, this one would have been great for prologue. I wish I would have just skipped 4 and gone to this one.
Yeah, I think you might find that 24 is also really fitting for Prologue, Cameron.
Yeah.
If you're going to do any more, you probably want to try that one.
Yeah, I don't. I'm looking at my solution, and there's not much code here. I did use a recursive solution, and the biggest challenge for me was again, I'm newer to Elixir language, and that's what I was using to solve these. And I was running into how do I manipulate strings and characters. Um, so when I look at my solution, it's really with the parsing. I mean, in total, it's about 90 lines, but most of that's just parsing, converting from strings to digits, um, and the regex to pull off the leading zeros.
Yeah, a common theme for me in my Go code was I would only use a regular expression to get the data that I wanted, and I just ignored all other symbols. So in a lot of
Hmm.
these, it was just a series of digits, and I knew the first one was the total. It didn't matter to me that there was a colon after it or anything like that. But the way I handled this was recursively with a oh, are we on? Which one am I on? We're talking about day 11, yes?
11.
Yes. Hmm.
Yep.
I think I read I did. I read the description for day 7. No wonder this didn't make any sense.
Mhm.
Day 11 is the Plutonian pebbles.
Yeah.
So the ancient civilization on Pluto, known for its ability to manipulate space-time, blah, blah. There's a series of stones. If the stone is engraved with the number 0, then it is replaced by a stone engraved with the number 1. The stone is engraved with a number that has an even number of digits. It is replaced by 2 stones. The left half of the digits are engraved on the new left stone, and the right half of the digits are engraved on the new right stone. The new numbers don't keep extra leading zeros. 1000s would become stones 10 and 0. If none of the other rules apply, the stone is replaced by a new stone. The old stone's number multiplied by 2024 is engraved on the new stone. No matter how the stones change, their order is preserved and they stay perfectly on their straight line. So my approach to this in the stones was just to recursively, I would sort of prime the pump and call a recursive function to see if I'd met my max depth, which they said go, was it 25 iterations? Yeah,
Yeah.
they called these blinks and they said, how many stones will you have after blinking 25 times? So I used this depth to see if I had hit 25. If so, then I would return 1, which was supposed to be a count of the stones. If the face was 0, I returned a count of stones with a count of 1, depth plus 1, max. Hold on a second here, guys. I lost my code. Um, and then this is the part of the code that checks to see if it's an evenly sized number, and if so, splits it in 2. Otherwise, it returns that face value times 2024. And that ran fairly quickly, even on a slow machine. It was like 9 milliseconds on a an old Intel i3. The let's see here. The part 2, Juan, this is what you said made you laugh out loud when you saw the change, and they said
Yeah.
basically run the simulation 75 times. So I changed it with my main code and ran it again. And on the laptop I was running on, it just sort of sat there, and then the fan came on, and you could tell it was chewing up resources. So in the second one, our second attempt, the main thing that I changed was I built a map of strings to int, and at each level, when I was in this recursive function, I would take the face value and the depth, and I would create a string out of it as a key that was face value underscore depth. And I would, every time I fell through the computation, I would remember that computation in that map. So I was memoizing this function call because the what was chewing up CPU time here was all of these recursive calls that were redundant. So basically this is a cache, similar to what a browser does with a get if it sees the same get URL. And I built a version of this that's timed, and this runs in about 75 milliseconds now for 75 iterations. So I was kind of amazed at what caching that uh, would do for the runtime.
Yeah, as you said, there's no, it just I just laughed because these problems typically part two has quite a bit extra language to adding to it, and then it was just basically that one sentence. So
Yep.
I knew that this was not going to work the way I probably had written it, and sure enough, I ran it. I think I was stubborn enough to let it run for 30 minutes. I walked away from it and came back, and it was still chugging, and I was like, all right. Then I thought I would spawn off all the available threads uh, on my machine. It still was taking too long, and then I did as what you did. I think most people probably came to the same conclusion to memoize it, and then it was done pretty quickly. And I used a library. I added a dependency, and then it was really slick because all I needed to do was change the definition to def memo, and then it handled the rest. So it was
Oh,
pretty slick. Yeah, I was
very
pretty
cool.
impressed with how quickly that went.
Now I actually gave up for the most part at day 8. That one threw me, and I had made it a week, so that was kind of a big deal for me to make it that far. And then I had Juan, you when you brought up this last problem we just talked about, this plutonium pebbles, um, that kind of got me intrigued, if you remember, because I did part one over lunch after we had chatted, and then I finished the part two up that night. I did some of these others, mostly just the first problems. Um, some of them I did both. Um, not many of them though. And the last one I did was day 24. So we talked when we had our last episode about some goals that we had. One of them we it wasn't really a goal, but we said we'd start our own leaderboard. So I did that, and we got well, we got our heads handed to us by this fellow named Stefan Holdermans, basically. Um, my friend Mike Ask joined us for a little while. He was doing the competition in JavaScript, and I talked to him a little bit, and it was after problem 6A that he decided, okay, he'd spent enough time at this, and he kind of stopped from there. Mine's kind of spotty here. Juan, I see you did some more here. Stefan, I found his GitHub repo and I've looked at them. He's doing all his in Haskell, which is kind of interesting. And the the code is pretty Spartan too. So I'd like to go back and take a look at each one of those in more detail uh, as we go along.
Yeah, I peeked around. It was really cool to see someone that one we have never talked to
Yeah,
join this leaderboard, and then we were able to look at his code and solve pretty much solved every day. It looks like he's got part two on the 24th and 25th. So pretty impressive.
yeah. He
So
he might have well, I should check. I should refresh the leaderboard here and see where we're at. No, he hasn't updated those yet, but you know, he probably had to take time off for Christmas because he was really cooking through these.
yeah, it's pretty impressive, and it's always fun to read. I haven't done much Haskell. I played around with it for a little bit, but I wouldn't say I got very deep in it at all. But to go back and look at how the problems get solved within Haskell, I know you can do it many ways, even within a programming language, but I learned
Hmm.
something by reading others' code. So I'm excited to take some time here in the new year and poke around on the problems that I thought were interesting, like the Pebbles one, and see how
Mhm.
how it was solved on that, and then even some of I the graph ones, the 2D arrays essentially were that are maps. I think we all kind of were burned out of here's this map,
Yep.
and essentially a 2D array is kind of usually how I represent it. And I was like, okay, and those ones I tended to skip this year because once I had done one or two of them, I was like, oh, okay, I want to try
Yep.
something different.
Yep. Yep. Agreed. The ones that I enjoyed, there were some that you implemented a small VM and others where you'd implement little interpreters. The VM one was kind of interesting because after you figured out the VM, part two was to find out there were three registers in the VM that were primed to certain values and would output numbers separated by commas. And the input was actually numbers separated by commas as opcodes. And what what you were supposed to do for part two is say, what does the A register need to be preconditioned to in order to output the source of the input? So it basically saying, what does register A need to be to produce a quine? And I couldn't for the life of me. I tried to do that iteratively, and the answer when I went and looked at others' code was something like 2.6 trillion or 2.6 quadrillion or something like that. Something that it would outlive, my machine would have to live, I don't know how many thousands or millions of years to finish that computation or get that far. So I've got to go back and see how to appropriately compute that. And I saw some of the discussions on Reddit, and what they were kind of doing there was taking the opcodes and they were doing some formulae on those opcodes to sort of uh, compute skip ranges, I believe, so that instead of going iteratively for the A register, they were they were computing only valid values that would make sense for that, and that seemed to make a difference. So I'm going to go back and take a look at that one.
Let's see. It looks like we both tried 19 as well. And that one, oh, that one was about the towels and the towel length. That one was a fun one.
The towels and the linen layout.
Hmm.
Oh gosh, do you guys want to? Well, tell me how you solved that one.
I basically all I think for most part these are all recursive functions, with the exception of the hit the A button and B button, which we can talk about here maybe in a minute. I just thought about my general approach to thinking about that one was like following a path and consuming the next character and looking to see what the next path would be, is because I was just thinking about inching my way through as
Uh-huh.
I crawl through, and that's generally the approach of how I solved it, through recursion, by consuming the next one and then consuming the next one.
Okay. I'll show you my solution to that one. If you thought I had a sleazy hack before, with some of these others, that was day 19. Um, yeah, what I did was I took each one of those strings in the input and I concatenated them together. First of all, with this as a prefix, the circumflex and a parenthesis. Then I separated each of them with a pipe, and I ended it with a parenthesis, plus, and a dollar sign. And basically just took the input and made a dynamic regular expression, compiled it in Go, and then applied that to all of the input, and that was it. And actually, the code here, um, I'm going to have to, I'll show you what happens from the input. Let me get a decent sized console screen here up, and I'll get that shared. Let's see. Here, let me stop sharing this screen and let me share a console screen. Okay, so what I did was apply day 19A to input.text. Well, let's start out with the initial one. What would happen is it would take the values that were in the input and just form its own regular expression and then count the number of matches, which was shooting fish in a barrel. And it's kind of funny once you see the regex that gets built um, or for the actual answer for part one is 285. So I didn't really do anything other string concatenation and regular expression compile on this one.
Let me see if I can share my screen here. Oh, nope, looks like it's disabled. But essentially, yeah, that mine was just crawling the next character and then kind of walking down this. I called it string muncher.
Here, try now one. Can you share now?
Let's see here. No, it might require us to rejoin. So
Okay, sorry about that.
no worries.
It's probably something in the setup.
Yeah. So I can't think which one we were just talking through that was the push buttons A and B. I don't remember which one that was, but I do recall that I thought immediately there's a math formula for this. And so that's one where I immediately went to look on the internet for a formula that would solve that. And that's where you have a prize, and it's the machine, like the claw machine.
Oh, the claw machine. Yes.
And it gives you an X and Y coordinate. And it says you have two buttons where the A button takes you so many X and Y, and then the B button takes you so many X and Y, but there's a cost of 3 tokens for one of them where there's only a 1 token cost for the other. And then is it solvable? Can you get a prize? And if you can get a prize, what's the least amount of tokens that you can spend on that?
Sure. I did that brute force, which is the way that I did all of mine. So my regular expression was a little different in that I took button A, button B, and prize as inputs in addition to numbers. And yeah, I think I just brute forced the distances that it would move for part one, and I never did finish part two.
Yeah. Yeah, with the formula for doing it, I think my code was 30 lines where 10 of it was just writing the formula.
Interesting. I'll have to take a look at that.
Yeah, I'll have to post it here this weekend.
Yeah, I'm curious how that worked out. What was the problem description for that one?
Let's see here. Yeah, the lobby of a resort on a tropical island is where you're at. The historians take a moment to admire the hexagonal floor tiles before spreading out. Fortunately, it looks like the resort has a new arcade. Maybe you can win some prizes from the claw machines. The claw machines here are a little unusual. Instead of a joystick or directional buttons to control the claw, these machines have 2 buttons labeled A and B. Worse, you can't just put in a token and play. It costs 3 tokens to push the A button and 1 token to push the B button. With a little experimentation, you figure out that each machine's buttons are configured to move the claw a specific amount to the right along the x-axis and a specific amount forward along the y-axis each time that the button is pressed. Each machine contains 1 prize. To win the prize, the claw must be positioned exactly above the prize on both x and y axes. You wonder what is the smallest number of tokens you would have to spend to win as many prizes as possible. You assemble a list of every machine's button behavior and prize location, your puzzle input, for example. So these were the inputs for each. And then, oh, yeah, this was the one where I didn't really even try. Basically, it says as you go to win the first prize, you discover that the claw is nowhere near what you expected it would be, where you expected it to be, rather, due to a unit conversion error in your measurements. The position of every prize is actually, what is this, million? billion, a trillion higher than both the X and Y axes. So you couldn't just apply these numbers and expect your code to finish. And when I looked at some of the solutions for this, it involved computation of, I believe, the greatest common divisor and least common multiple. And you could figure it out that way. I didn't try part two after just seeing how hot my machine would get for a few seconds after trying to, add a trillion to the input values.
Yeah, that's a tricky one.
Yep. Yep. The part twos were often kind of tricky. Um, Cameron, the one that I kind of liked that I thought you might want to try in Prolog was one that I mentioned here with logic gates. And your inputs are basically uh, either variable values or ands, XORs, and ORs across these gates. And I'll tell you, it took me a while to figure out what exactly they were after here. You don't process these sequentially. You have to load them all up and then solve for all of these Z expressions. So you load all of this up, store your variables somewhere, and then solve for these Z expressions in reverse order. So they want you to, if you've got 20 Z's, they want you to start with Z20 first, then go to Z19, then Z18. And the number that they want you to compute is one that you need to take the bits from each one of these Z's and shift everything to the left and OR that in every time to compute the final number, which I thought was I thought the whole problem by the time I was done with it was just kind of a pain, but it was a fun exercise going through these computations, and I think this might lend itself a bit to Prolog more than the others.
I also think 23, because that's when I actually started looking at using Prolog to solve.
Let's see.
And that's the one where you have it's a network question where you've got machines that gives you a list, and it talks about them being bidirectionally um, networked, and then you got to find,
Oh, the LAN party.
yeah, the LAN party with three of them.
Oh, yeah, yeah. Yeah, I think this probably is a good one as well. This is basically in this one, they want you to, they have these associations of a left pair and a right pair, and they want you to find basically the triangles where the left pair, right pair, they meet up with another left pair, right pair, and then there's another left pair, right pair that joins it back. And I like most of these, I just brute forced my way through part one there. Um,
I
part two.
started to use mini conron within Elixir, so that was stretching, running that paradigm within the Elixir programming language, and
Hmm.
I got it to work. The challenge I ran into was the input was so large that I didn't know how to dynamically add goals for it to solve, and so that was something I've been working through, and then I was like, well, let me just solve it. So I switched over to Prolog last night to see if I could get anywhere, and I made some progress, but I've got a couple of things to clean up, and I think I'll have it. But the camera, I thought this would be a good one that if you solved it or did it, maybe we could compare approaches on that.
What was that you mentioned? Mini Conron?
Yeah, it's a logic constraint um, language.
Oh, within Elixir, like a
No, no,
DSL.
it's its own thing.
Oh,
But
okay.
there's a library that implements it within Elixir, and I use this core logic is what is similar. Well, similar. It's the same thing, but it's for closure. So
And I think I might be wrong, but I think Mini Conron was covered in one of the seven languages books.
Yeah, I think you're right. I think that's how I first got introduced to it.
So if you happen to have one of those laying around, Cameron, you might take a look.
It's fun. It's very if learning Prolog made me a lot better at using that language.
On the second part of this, though, and I haven't attempted it, I looked at it, was I think what they wanted you to do is through all those associations, find the largest group of computers that was all interconnected together. These are all supposed to be computers at a LAN party. So you had to go through the connections and find the ones that were all interconnected with each other, basically. And I didn't try that one.
Well, now I know what to look forward to.
Yeah, I quickly scrolled by the answer here. So if you're if you're watching this episode, Juan, cover your eyes so that you're not tempted to cheat when you see the answer to part one.
It's fine. The inputs are different.
Um, so I'll tell you a few things I learned out of this. I jotted down some notes here so you guys are seeing some things. I have the same boilerplate code, read the text file, the first argument, handle the errors. I use regular expressions with each one to extract the tokens, and it's just dead simple to do that and go. It's usually just numbers as input when I have to do that. Um, for some reason, my regular expression variables, both the string and the regexp data structure, were globals from whatever code I copied it from. So that pervaded through most of these, and it really shouldn't have. They should have been, you know, style wise, they should have been in the main method. I found that Go is missing a few things like an integer absolute value function. So I think when I do this again next year, and I probably will, and I'll probably use Go again, I will probably make a library that handles all of the input, and I just feed it a regular expression to, parse those out so that I can simplify the boilerplate a little bit, and then I'll add in those missing functions like absolute value. I did run into an issue with, I think it was problem 8, where I was misusing Go's parameter passing, and I think I ended up passing a copy of a map in to a function. And when I changed the value, nothing happened when it came back out. And I just needed to pass that in as a pointer. But this is where I was a bit uh, unfamiliar with how that worked. So I think those elements of the language are sort of the next thing that I wanted to try. I did also notice too that this was my first year posting any of my results on Reddit. And I got a nice little bump on various social media platforms. But when I posted on Reddit, I noticed that most of the folks that posted there posted the timings on how long theirs took to execute. And so I built that into one of the other examples, that example 11. I just tried it because I wanted to see if my approach to the second part was actually faster than my approach to the first, and it wasn't when I memoized those. But and most the thing I found kind of funny is the ones that I saw posted that had the this executed in so many milliseconds didn't spec out the machine that it ran on. It was just, well, it ran in 300 milliseconds, but on what? On an Intel i7 under Windows? What on one of the new high-end Macs? What were you running on here? Um, did you guys get what you had hoped to get out of this as far as Cameron, you talked about learning modern Prolog, and Juan, you wanted to sort of warm up to Elixir again so you could
Mhm.
dust off some side projects. Did that happen for you?
Yeah. I haven't dusted those projects off. That's looking like it's gonna be maybe next week, but certainly it got me excited. Like there's just like this inertia of doing the learning and getting better with the language that I I have to get over, and now I'm in that comfortable like, all right, let's see what else we can do with it. So it definitely did some learnings. It's interesting as you were talking through some of the things you'd put in going next year, what you have. And as I finished solutions and would go back and look at others, I would see that folks had already like a 2D array little snippet of code ready to go in whatever problem they were solving, and it had nothing to do with the maps or the 2D arrays. I was interested, like, oh, okay, that's cool. And it was fun to see recursion done in other in like Python, seeing folks do it in that. And I was like, oh, okay, because Python's not something that I've explored a whole lot. I played with it when it was going from 2 to 3, and was really, really thought it was great, but I didn't get a chance to use it in my professional career. So it kind of fell off for me in its usage. But to see other people and what they can do with that language, that's fun too, to see what others are doing with the languages that they're choosing. Yeah, I certainly met my goals. I feel pretty good about where I took this competition this year with the language. And hats off to the coder that got all of them done, because that's pretty impressive.
That was Ranger McSexy. He stands as the leader right now, but that could change.
Uh, I did not meet my goals, really. I mean, I didn't get very far. I mean, I guess in one sense I did because I know more Prolog than I did before I started. So that's good. But I tried to prepare, I got a book ahead of time and, kind of went through that a little bit. But I really underestimated how difficult it would be trying to trying to go into these problems with a new language. Um, I mean, I struggled on every single problem. I really struggled with it. Just doing the basic stuff like string manipulation and trying to figure out how to do that. And at first on day one, I was every single thing that I did was recursive. Um, and that kind of continued on up to day three and day four. But I kind of started to figure out things a little bit by day four. But gosh, yeah, I didn't get too far this year. I think next year, I think I'm just going to use a language that I'm really comfortable with, and then see how far I can get.
Sure. So I'll,
One,
I'll 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 tell you my experience. If excuse me, just a second, one on that note. My goal was to use Go to kind of make sure the language stayed out of the way, so that I could just work on the problems the way that I was thinking about them. And for the most part, that worked. I really didn't have the well, this implementation of the GCC that you've downloaded doesn't have threads or something along that. I'd run into something with the language environment, the library, something like that. Go just stayed out of my way. So this was the first competition in the last. So this is probably my sixth time at this. This was the first one that's really been halfway fun, because I could just do the examples, get the get the results or not, and call it done for until the next problem.
I like that it's only halfway fun. That's good.
You know, Juan, you were going to say something. I'm sorry.
oh no, I was just gonna comment to Cameron that when I looked at day 23, as I look at it still, with a Prolog solution, I fully am gonna make that input look like Prolog code. So I'm gonna change it, not have to do the manipulations, because for me that's not gonna be the thing I'm gonna focus on. Is just like putting it together. So I'm gonna make my fact table, if you will, out of the input, and then read them into the code, so that I could do all the manipulation outside of it and kind of pull myself away from having to do the parsing part, which is important. But at this point, I just want to solve the problem and not have to
No,
worry about it.
that's a great idea. That's something I never had even considered, was manipulating the input, but I guess there's nothing stopping you from manipulating the input.
Yeah,
So, yeah,
use the tools that you have.
yep.
I will say too that I did look at some other folks' code. If I wanted to just see what the number was, or the value was that I was supposed to be getting to, I would go get a Python example and run it and see what the answer was, instead of wasting my time trying to post answers that weren't working, so I could see if I was working how close I was getting to something. And also I found that I looked at some Go examples and I found that my Go is very Fortran looking in if you take a look at it, variables I, J, and K are all integers, that sort of thing, with very little in terms of putting abstractions into the code other than functions. I think I only used one or two data structures. Most of the Go code that I looked at had a lot more elaborate problem decomposition with different types of structures and modeling so that their intent was probably a little clearer than just this guy wrote this nested for loop and he's doing this and somehow he comes up with the answer. So I thought that was interesting. I don't know that I'm going to change my approach terribly for next year. I'm probably going to use Go again.
Yeah,
And go ahead, Cameron.
yeah, I was just gonna tell Juan, I did do a lot of dynamic assertions to just kind of create facts like at each step in these problems that I did do. Because I don't know how to debug Prolog really. I'm sure there's probably a nice way to do it, but I don't know how to do it very well. So I was just using assert A and asserting facts all over the place so I could look at the data and see what's there.
I did want to give a shout out to Tim Holyoke, who I found very early in the competition was writing all of his solutions in Fortran 77. Uh, he did that for most of them. I've looked through some of them, and some of them he needed some richer features, so he went as far as Fortran 90, I think. But he got through something along the lines of 47, 46 or 47 of these problems complete using Fortran by Christmas Day. Um, I got 23 coins this year. That is a new record for me. So usually I'm out in the first week and so this was better than most. When I could steal time, I'd try another problem.
I had a record low number of coins I can celebrate this year.
Okay, guys, any closing thoughts about the competition?
Felt like this was one of the years I was more engaged with the problems since 2015. I felt like maybe this is another one that I might go back and actually complete the whole 25 days.
Very good. All right, guys. Well, thanks again for being on the show. This was fun. Thank you all for watching today's show. Let's do this again soon. Take care.